The gleaming skyline of the city is a living being with its chrome, glass and concrete extravaganza. Skyscrapers proclaim a city that has joined the ranks of the elite. But at what cost? Today, climate change is one of the most serious threats to our planet. And in this grave environmental crisis, buildings and urban constructions insidiously emerge among the most menacing offenders. Buildings use twice as much energy as cars and trucks, consuming 30% of the world's total energy and 16% of water consumption. By 2050, they could go beyond 40%, emitting 3,800 megatons of carbon, the main cause of global warming.
Now in India, as in many developing countries, some 1/4 of our energy goes into buildings, into making buildings and into operating them. Almost a half of our materials that we dig out of the ground go into the construction of buildings and roads and other construction projects. So it is a very large part of the cause of our environmental problems. So from that point of view, it's extremely important that we demonstrate that good buildings, comfortable buildings, productive buildings can be made using much lower cost and much lower energy materials and techniques.
Development Alternatives, a non-profit society set up in 1983, has over the last 2 decades pioneered projects on sustainable habitat and housing at the rural level, developing low-cost and low-energy technologies. As an extension of their beliefs, way back in 1986, the DA headquarters was designed as a mud block building.
The original dream, the vision that we had, was to create a workplace where young people could give their best, their total creativity to nation building.
20 years down the line, DA has grown to an organization with over 200 people, making significant differences in national housing for millions of people. The time for change was inevitable.
So it was sad for all of us when we had to take the decision to pull it down. But it had to be done. It had to become contemporary. And we had to look at how that whole spirit of being in a sustainable building, a building that belonged to the earth, could now become more contemporary in real time. And that's how this new building was then conceived. We had more people to accommodate, but we had the same, ethos that we had to maintain.
So the story began of creating a building that took into account the impact on environment from each and every brick that was to be placed, to each drop of water that was going to fall on the land, to each and every ray of sun that touched the building, creating not just a building, but a living ecosystem.
One of the challenges was to see how you can express a continuity of that ethos through this building. While you're actually inventing new technologies and you're scaling up the technologies that were developed, say, at workshops like that of DA and many other such organizations. But you're scaling them up to another level and finding a new aesthetic and trying to maintain that continuity across from what has been their inheritance and what are their aspirations.
After months of planning and brainstorming, the DA building started taking shape, looking extensively into each and every minute detail that would make it a carbon neutral building. From raw material, design, utility, environmental responsibility, traditional masonry and construction style, the idea being not to just create a green building, but a model for others to follow.
The mud used in the old building has been recycled into blocks. They have a little bit of cement and a little bit of sand, and they are customized precisely for usage in this building.
Three kinds of bricks have been used. Waste fly ash from thermal power stations is recycled into high strength and quality bricks. These are used to form the outer wall. Compressed mud blocks to form the inner wall. The conventional red brick made in more energy efficient kilns developed by DA interspersed throughout the building. The three providing a variety of textures and designs, yet durable enough to withstand the rigors of rain and other elements for years to come.
What we found is that masons have got spoiled over the years. They just tend to stack up the bricks and throw plaster over it so that all the work and all the mistakes also get covered. Now in this, we had to get the alignment right. We had to get the consistency right. We had to get one or two very skilled traditional masons, use them as trainers to train the other masons, and then at each point of time do quality checks to ensure that their work was consistent.
These are ferrocement roofing channels or roofing shells. These are prefabricated elements which work on the principle of the very thin, slender eggshells. They are made exactly to size, so means there is no material wastage. Secondly, they cut down the consumption of steel very, very significantly. The thickness of these is only 1 inch compared to 4 inch for an RCC cement slab, which means that we are using roughly 1/3 or 1/4 of the material, which is cement, sand, and no aggregate.
Previously, over the last 4 or 5 years, we have been propagating the ferrocement channel technology, but this one was wider, which means in fabrication, we had to make a new set of equipment. And again, more importantly, we had never taken it up 5 floors. So we had to get a completely new hoisting mechanism such that it could be lifted up to 5 floors and also put in place. This building, there are more than 200 of these channels, and we couldn't afford breakages because it was one of the most expensive structural elements.
In a tropical climate like Delhi's, with temperatures in summer soaring to 45 degrees Celsius and in winters going down to even 5 degrees at times, the temperature control of the building was crucial.
First, design the building such that it catches and absorbs as little heat from the outside as is possible.
One of the key features is the orientation of the building to the movement of the sun, keeping the east and west faces of the building blank. The walls are built in 2 layers with waste thermocol pieces in the center to help in insulation and climate control. To further combat the oppressive heat load, the roof is covered with a reflective surface made of leftover broken white tiles and sanitary ware, creating a homogeneous surface reflecting the rays of the sun.
Important decision that we took was in terms of the range of temperature that we felt we could tolerate. So instead of a standard AC 5-star environment of 22 to 25 degrees centigrade, we said okay, we can go down up to 18, 19 degrees. When it's very cold, we put on a sweater, it's okay. And when it's really hot and for a few days, 30 degrees is fine. And we are all wearing half sleeves t-shirts in any case, so it's okay. And we are comfortable in tolerating that, and it's a lifestyle statement we will make.
In most offices, air conditioners are set at a chilled 17 to 18 degrees instead of 23 to 26 degrees. All this means more power consumed. More power consumed means more coal burnt, more bad news for the environment. Moreover, in conventional buildings, the high use of concrete and glass retains heat within, adding to the cooling load of air conditioners. Almost 70% of the energy bill in Delhi is attributed to air conditioning alone. At the DA headquarters, a new air cooling system is being attempted.
Every floor will have a dedicated air handling unit, and these openings that you see are provided to fit these units.
This system is hybrid, a combination of a desert cooler with an air conditioning system, as well as a heat recovery system. In summer, the air is pushed into the rooms acting as large coolers. In the monsoon, the compressor sets in. The compressors are compact and use environment-friendly non-CFC gas.
And in the center of the building where we have a courtyard, we use that courtyard space to have a trickle fountain, which by evaporative cooling reduces the temperature within the courtyard during the dry seasons, and thereby reduces the heat gain from the courtyard.
With the external structure now in place, the play of light is apparent. The ingenuity lying in the simplicity of the design. From the moment the sun rises, the work areas are infused with natural light, thereby reducing the dependence on electricity and further reducing the stress on energy consumption. A stumbling block was acquiring wood for the building. On conducting market surveys, it was found that the Forest Department certified plantation wood was not readily available.
In our case, this being a green building, we had to ensure that only certified wood from fast-growing plantations was being used. For this, we had to go up to Nagpur, get to the plantation, get to the people who are certifying, and then bring in the wood up to Delhi.
The traditional method of interlacing bricks in shallow domes has also been used. The ingenious method eliminates the need for steel and cement.
पुराने ज़माने की कोठियाँ थी, वो क्या आज बहुत कम दिखने को मिलती है, कैसे कि जो गिर गई हैं वहीं थोड़े बहुत डोम दिखाई देंगे, और आजकल जो नई नई कॉलोनी बनती हैं वहाँ कहीं नहीं दिखाई देती है बनने को। हमको भी 32 साल में पहली बार ये बनाने को ये चीज़ मिली है।
The ceiling also has filler slabs instead of concrete. Earthen pots are used as fillers. So without compromising the structural integrity of the roof, aesthetics as well as the acoustics of the roof are enhanced. This combined effort of using ferrocement, shallow domes set between a skeletal frame made the total consumption of steel for a 5-story building about 30% less of what would have been used to construct a conventional building. With fly ash and mud blocks used correctly, the saving on energy is another 30%. Even the intricate pattern of flooring of large and small stones helps reduce the end wastage to just about 3 to 5% of stone.
So there's a whole slew of such actions which increase efficiency, performance at low capital cost and low energy consumption.
The basic underlying principle behind each aspect of the building is to reuse and recycle with minimum waste at all levels.
No single drop of rainwater will be allowed to move out of this land. So where it falls, it shall be conserved.
The slopes, drainage and piping are all designed to ensure that the rainwater will recharge the water table with permeable pavements and recharge wells. Even once used water is not to be wasted and will be recycled back. Finally, to maximize energy conservation, solar panels cover the roof. Interestingly, the system is set up for both water heating and to power up the electricity needs of the building. The DA Center for Excellence slowly takes shape and form in a synergy of the new with the old.
You know, this is the space where we had our dome. When it was constructed, it was the largest of its kind in the country. And this was a space where we would sit down, converge every Saturday, and we used to talk about our work, we used to share our work, and we used to be very critical of all that we were. And it was the stupa for us, it was the Buddha center for us.
Came up with a solution which said that, okay, we will retain the memory of that dome and we will transform it into a new kind of space. So now, instead of the dome being an indoor space, that cylinder becomes a circular courtyard which will have a bamboo fretwork roof which will be domical in shape. And around this cylindrical courtyard is the resource center as it turns around. So we turn it inside out.
So it's there and yet not there.
The need for a symbolic continuity of the old building.
Today, the DA building may be a role model, but I see tremendous potential when we look towards the future.
The future of construction in India has to be towards lower damaging, lower environmental impact approaches.